Okay, the last reaction you need to be able to do is an esterification reaction. So in an esterification reaction, we have an alcohol, and it reacts with a reagent called an acid chloride. So the first step should look very familiar to you. There's a carbonyl group. Here's a nucleophile. So the nucleophile is going to attack the carbonyl group and push electrons up there. And that's going to take us to a tetrahedral intermediate. So what was a carbon-oxygen double bond is now a carbon-oxygen single bond. And we now have an extra bond between this oxygen and that carbon. Okay, and you'll notice that I've been a little bit lazy and I haven't bothered to draw the subsequent step, which is a simple, boring acid-base reaction here to deprotonate that alcohol. So just send me a little message to indicate that you understand that that's happened in order to take us to here. And finally, this tetrahedral intermediate is going to collapse. So we're going to reform the carbon-oxygen double bond, and we're going to kick out this good leaving group, Cl-. So that will take us, so we've regenerated our carbon-oxygen single bond to a double bond, and now we've got an OR group attached. And the other product of the reaction is Cl-. The Cl- is not such an important part of the reaction. This is the one I'm interested in, and this, of course, is an ester. Now, you should also be able to do this reaction by, instead of using an acid chloride as your reagent, the alcohol would also react with an acid anhydride. Here's an example of an acid anhydride. I expect you to be able to do the same reaction using an acid anhydride instead of an acid chloride. That's it.